So I'm going to go over the difference between acids and bases. So if we think about a pH scale, 0 down here, 14, 7. So 7 for a pH is a neutral pH. 14 is a very high pH. And 0 is a low pH. The lower the pH, the more acidic something is. And the higher the pH, the less acidic, more basic something is. Right? So if we have something that's very acidic, that means that there are a ton of hydrogen ions in that something that we have. If something is less acidic and more basic, that means that we have a ton of hydroxides. And hydroxide's a base, and these hydrogen ions, these are acids. So acids typically have the lower pH because there's more hydrogen ions, and bases typically have a higher pH because there are more hydroxides. So today I will be explaining the strengths of acids and bases. Okay, so the difference between a strong versus a weak acid is that a strong completely dissociates in water or a solution. So for example, if we have our beaker and we have our strong acids inside, these are going to completely dissociate in our solution. And if we have our weak acid, they only partially dissociate in water or a solution. So if we have our weak acid in a solution, they only do like a little bit, dissociate a little bit, just like that. So an example of a strong acid would be HCl, which is a gas in water. And this is gonna break up into H3O plus and chlorine, just like that. And we can see that this arrow is indicating that this is gonna completely dissociate. Now an example of a weak acid is H2CO3 in water. It's going to dissociate into H3O plus only partially and H2CO3 minus. Now, as we can see, these arrows are going to indicate that this is partially dissociating because there's a forward and reverse to our reaction. So now, this is kind of the same idea with a strong versus a weak base. Right? So this is going to completely dissociate in water. Now with strong bases, these are formed from groups 1A and 2A on the periodic table. And our weak bases are going to partially dissociate in water or solution. Okay. Now, weak bases mean weak electrolytes. Now, electrolytes are those things that are in a lot of energy drinks. They give us energy. Electrolytes are basically code for salts. So, examples of a strong base could be KOH, and that's going to dissociate when put in water into K plus and OH. Completely dissociating. There's no forward and reverse. Now, a weak base, again, only partially dissociating and producing only a few ions in the solution. So we have our NH3, which is gas, in our water, and there's a forward and reverse, NH4 plus OH minus. Again, there's a forward and reverse, and this is only going to partially dissociate. And that's pretty much all we need to know with strong versus weak acids and bases.